Hello, everyone, online and in the room. Welcome to the next CLEA seminar, which is like a historic moment almost, because we haven't been here for like a few centuries. Yes, in this room. Still more people online, but actually like quite not just one or two, but like more closer to 6 in the room. So welcome everyone. We are starting a seminar which is thought like kind of designed to be more like a debate event than a single talk. We will have 4 speakers today debating something which we say we are busy with, and let's see if we agree, if the thing that we say we are busy with we like understand in any like way that you know, like matches other people understanding. So the topic is transdisciplinarity, not kind of like an ideal object in a sense that we have an idea and we have a definition of an idea, but the question that we are addressing is more how we are doing what we say we are doing. You know? So like a group of people in a room, a group of people on Zoom, a person sitting on a computer, a person doing some sort of research, when they say they are busy with transdisciplinary research, okay? So like how this activity is conducted. That was the question. Let's see what our speakers for today will bring to the table. And after the few talks, we'll have 4 talks of about 20 minutes. We'll, you know, like put those perspectives together. We'll discuss. 2 people will be speaking from the online environment. Marcin from Japan. Marcin, you are based at University of Tohoku, if I'm pronouncing.
Tohoku University, yeah.
Yeah, in Japan. Marcin Schroeder and Michael Woodley of Many, who is speaking to us, I believe, from the UK. Yes, Michael, or some I don't know. Okay, he's muted. Michael, can you hear us? If he can, we cannot hear him, but we will hear him soon. So 2 online speakers and 2 speakers from the room. One is present and one is stuck in a train. So we'll arrive. Karin Werast was supposed to be the first one. She will be the last one. Francis just the other way around. So Francis Heylighen will start. I'll be trying to keep time. Okay, so let's go for it. Francis, I will share your presentation. All right.
Okay, so for those who don't know me, maybe online, the director of CLEA, and CLEA stands for the Centre Apostle, and we have kind of defined the Centre Apostle as a center for transdisciplinary research. Part of the debate is what do we mean by that, and is that really the right way to describe what we are doing? So mostly I'm speaking about research because CLEA is a research center, but CLEA recently has also been going more into education, and it's one of the things we want to discuss now is, can we develop something like courses on transdisciplinarity? So what is transdisciplinarity? Well, first I want to distinguish it from interdisciplinarity or multidisciplinarity. Interdisciplinarity, in my understanding, is when you work somewhere in between 2 or more disciplines, like, let's say, biogeography or molecular biology. You combine biology with molecules or biology with geography. The problem is usually after a while, these kind of interdisciplines become themselves disciplines. So that is not really what we mean. Then there is multidisciplinarity, where we have lots of disciplines contributing to some big problem that demands lots of expertise. Yeah, that's part of it, but it's not more than just having the disciplines together working on something. It's what we call transcending the boundaries between the disciplines. At least that's how I understand these terms of transdisciplinary. That means that you have boundaries and you go beyond the boundaries, you go above the boundaries. So you look at it from above rather than putting yourself in particular domain. So roughly speaking, that is research that is not bounded, that is not encapsulated within a domain. And these domains nowadays are often called silos to kind of emphasize the fact that they have pretty strict walls and that you can't easily move from the one to the other. And by transcending the boundaries, I mean basically not a priori recognizing boundaries. So there is no a priori restriction on what topics you look at, what objects you consider, which phenomena you investigate. And another connotation of transdisciplinary for me is that you try to integrate, to unify the different disciplines, and that was the original aim of Apostle when he defined the mission of the CLEA Apostle, that is integration as a counterweight to the fragmentation into ever more specialized disciplines. Now, there is one important distinction that we must make when we speak about transdisciplinarity, which here I have called practical or applied research versus basic or fundamental research. More recently, there is a new understanding of the word transdisciplinarity, one that I actually only discovered relatively recently by talking with the vice sector of research of the VUB and saying that we are doing transdisciplinary research. And their reaction was, yeah, you mean research that involves stakeholders from outside academia. So that is now a kind of an additional meaning that this transdisciplinarity has gotten, like interdisciplinarity is you stay within a number of academic disciplines. Transdisciplinarity would then mean you involve people who do not belong to an academic discipline, who are people who in practice are confronted with the problem. And if you want to solve the problem, you need to involve the people that have the problem. So transdisciplinarity in that sense, in the sense of not just involving academic experts, but involving non-academic stakeholders. On the other hand, the older interpretation of transdisciplinarity, which I was sketching before, is this idea of that you want to go towards a unification of the sciences. And that is actually an old movement. There are, roughly speaking, two big attempts at doing that. One was in the beginning of the 20th century with logical empiricism, which was a very analytic approach of trying to formulate a language that would apply to all of sciences. And then later, around the middle of the 20th century, the general systems theory. So what I'm going to argue now is that these two interpretations, let's call it the fundamental one and the applied one, that they are actually quite compatible because they ask the same kind of questions. They have the same kind of problems that need to be solved. So here is an example of this newer approach of transdisciplinary research. These are two recent books, I think 2011, 2012, that are specifically looking at these practical cases. Now, the first one, the Handbook of Transdisciplinary Research, I have quickly gone through it. To me, it seems just like a collection of practical cases, all kinds of cases where there is some complex problem. The second one is more interesting in the sense that they also have practical cases, but they have chapters on general methods. Unfortunately, these methods, as far as I have read them, they kind of state more or less the obvious. So the obvious is you bring together different people, you discuss, you look at it from different perspectives. I'll try to go in this talk a little bit beyond the obvious and try to start mentioning some of the elements of what a transdisciplinary methodology could be. So to define the transdisciplinary methodology, you first need to contrast it with the methodology of a traditional discipline. A traditional discipline, one way to say what it does is it's something that defines its problems. So a traditional discipline starts by demarcating its domain of application. For example, biologists look at living systems, psychologists look at the human mind, chemists look at molecules and reactions between them. Then they also more specifically demarcate or define the questions, the kind of questions that they are investigating. For example, biologists might look at which genes are responsible for particular biological characteristics, and chemists might look at how you can speed up a particular reaction between certain types of molecules, and psychologists might look at what a particular emotion has as an effect on how people behave. Moreover, these disciplines provide a number of methods and models to tackle these problems. So they have methodologies, for example, psychological experiments, particular ways of observation, particular types of models that we know from experience work to answer these kind of questions. And if you go even deeper, you might say that at the most fundamental level, what all these disciplines do is they have what is called an ontology. An ontology is a kind of a assumption about what are the basic elements of reality. What are the elements that you can distinguish? Like in biology, this might be organisms, they might be genes, they might be ecosystems. In chemistry, they will be reactions or molecules. They have an ontology. So now, to contrast this disciplinary approach with the transdisciplinary approach, we need to notice that there are a whole lot of problems that do not fit into this category, these so-called ill-defined problems. So problems where it's not very clear what the problem is, and there are different names that have been given to these problems. One of the more famous ones is the wicked problem. We also speak about complex problems, about open-ended problems, about ill-structured problems. In other words, these are problems where it's not very clear what distinctions you make. You are not quite sure where the problem begins, where it ends, what its elements are, what kind of models can be applied, what kind of methods could be applied. So you see lots of aspects that have something to do with it, but these aspects are interconnected, they're entangled. It's difficult to separate them. It's difficult to classify them. So they are open-ended. You don't know quite what's in and what's out of your problem domain. So it's for these kind of problems that I would say you need intrinsically this transdisciplinary research methods.
Francis, I'm sorry, because somebody wrote on the chat that they cannot see the presentation. So it got unshared. Sorry about that. Stops to be shared when it goes full screen. So maybe let's keep it like that, okay? Because it unshares it when you go. Yeah, okay. This should work.
So I've defined the transdisciplinary problem as this kind of ill-defined, open-ended problems. Now, within these very broad categories of ill-defined problems, I could, which is a more heuristical kind of distinction, distinguish three types of problems. The practical or the applied problems that I spoke about, these are the problems typically that we have in the real world, where things do not belong a priori to a domain. And an example I thought of is, what is the impact of the COVID pandemic on society? Once you start looking at that impact, you see that it's much more than health related, it's much more than society related. It changes culture, it changes politics, it has an effect on social media, it leads to conspiracy theories. These conspiracy theories get propagated via particular algorithms used in social media. Because of the conspiracy theories, people may or may not get vaccinated, which then influences the dynamics of the disease, which then influences the other measures that need to be taken. This is typically an example of this kind of wicked open-ended problems, where you can't quite say what's in there and what's out there. The second type of problem I have called exploratory or out-of-the-box problems. by this, I mean problems that are more traditional scientific problems, but where it doesn't fit into a box because it intrinsically transgresses the boundaries between disciplines, because it typically combines one concept from one discipline with a concept from another discipline that at first sight has nothing whatsoever to do with it. And one typical example of CLEA research is quantum models of cognition. Quantum mechanics is a formalism in physics describing particles. Cognition is what happens inside your brain. There are initially some analogies, but these analogies are very vague. Getting them in more of a model is typically a transdisciplinary problem. And then finally, what I would call the philosophical or the foundational problems, which are also the problems where CLEA is particularly interested in. These are more the ones of unification across the different disciplines, like going towards more of a coherent worldview. And one example, for example, that we have very recently started looking at is the definition and origin of life, which is not a biological problem because you're starting to speak about something before there was life. So you need to involve at least physics and chemistry and lots of other things. Or another one might be, how is science being done? What is the epistemology of getting knowledge about the real world? These are these kind of foundational problems. Now I need to change in the different tool. So let's say that I have this ill-defined transdisciplinary problem. How do I start dealing with it? Well, I think there are some general questions that anybody who starts any research that is not well-defined should ask. So the first question is, what question or what problem am I trying to tackle? To give you one example, I had a student who wanted to make a master's thesis about AI and health. Now, what is AI and health? What is the problem there? First, what do you mean by AI? What do you mean, in this case, by health? He seems to imply that there are certain methods that use AI algorithms maybe to diagnose people or maybe to cure them. It's not a well-defined problem. So the first question is, what really is the question I'm going to look at? AI and health is not a problem, but maybe the abuse of AI algorithms in order to get data for people in health domains could be one problem, or there could be others. Second question is, well, if you start with one of these open-ended problems, well, obviously there is not a standard way of looking at it. There are different perspectives. So what are the different perspectives on the issue? Go a little bit deeper. What are the different factors? Which are the different elements? Like AI, do I mean robots? Do I mean recommendation systems? Do I mean data mining systems? Health, do I mean people in hospitals? Do I mean people who follow diets and are following some kind of a regime to get healthier outside of hospital? What are the elements, the factors, the components of the problem? Once I have the elements, I of course need to look at what makes it into an interesting problem. How are these elements connected? What's the influence of the one of the other? And in particular, if I'm interested in what may happen, if one of the elements changes, what will it have as an effect on other elements? And also interesting, it's not enough to have lots of elements interacting. I would like ideally to see some pattern emerge, something there that is more than the sum of its parts, some new insight. So these are some of the general questions that any transdisciplinary research should do. So let's go into a little bit more detail on how we could do that. So a possibility of a strategy is, first, you roughly delimit the domain of inquiry. You say, for example, which AI terminology, the technologies you include, or which aspects of health you include and which you don't. Then you locate sources of information, which could be disciplinary experts, which could be stakeholders, or which could be just sources that you find on the internet. You go through all that, you talk with the people, maybe you bring them together, or maybe you just read their text. You collect a variety of ideas and perspectives relevant to your problem domain. Of course, you should be aware that whatever perspective you have will be limited and will be biased because it looks at it from one particular point of view. And often lots of these perspectives will have certain hidden assumptions, things that are so obvious that people don't state them. By making them explicit, you may become more aware of what the limitations are of this particular perspective. Once you have collected different perspectives, you can start to see, are there agreements or disagreements? Like I have read a number of papers about AI and health. Maybe some look at it more as something positive that can help, while others warn about particular dangers. As long as there are agreements, you have a good basis to start with, but of course you should still remain critical. When there are disagreements, that's where it becomes more creative. Like, can you find a way to resolve these disagreements? But be aware that there will always be different perspectives and it's not necessarily possible to integrate them. So the next step, once we go into a more detailed research, is to build a model. Now, I need to be very careful in defining what I mean by a model because lots of people mean different things with it. So a model is an idealized, that means simplified representation of some problem domain. Now, by a model, anything can be a model. It does not need to be a mathematical model, does not need to be a simulation, does not need to be a formal model. As a very simple example of a model I give, a doll. A doll can be used as a model of a baby. If you want to teach, for example, people in a nursery school how to handle a baby, you're not going to let them handle real babies, you're going to let them handle a doll, which ideally has the right anatomical proportions and the right weight, so that you know that you can carry the baby like this, but you can't carry the baby like that. The model of the baby, that the doll, is of course a very simplified model that excludes almost everything interesting about the baby, but it includes some things that are relevant for your problem. Namely, if your problem is how to carry a baby, then the doll may be a relatively good model. So models are intrinsically subjective because they include certain things and leave out other things, and what to include and what to leave out, that is the subject who chooses that. So in one of these papers that I was looking to, there was a nice statement, something to the effect that a model is always a model of something. That means a delimited phenomenon. For somebody, that means for a particular group that wants to use that model for some purpose. So the baby doll can be a model for the purpose of learning nurses to carry babies in a safe way. So models are subjective in that respect, but a good model, you would also like to be objective in the sense that the model allows you to make predictions. A good model like a doll of a baby allows you to make the prediction that if you carry a baby like that, it will be stable, but if you carry a baby like that, it will fall. So good models make predictions which turn out to be correct in practice. So how could we go about transdisciplinary approach of model building? Well, to start with, we need to clarify the elements, or what I call the distinctions. We started by the assumption that the problem domain is not well defined, so you need to define at least some elements. You can look, for example, what are the objects in my problem domain? What are the agents? Which are the properties of these objects or these agents? Can I group these objects or agents in different categories? And important, what are the variables? What are the things that can change, that sometimes are there, sometimes are not there? Once I have that, I can start looking at the relationships between these elements. For example, when I look at categories, I can see that one thing belongs to a certain category, which itself belongs to another category. I can look at part-whole relationships. babies have parts like this and these organs. And I can finally look at causal influences. If this changes in this way, then it will make another thing change in another way. And there typically we will look at positive effects. When one thing goes up, then the other one goes up as well, or negative effect, one thing goes up, it suppresses something else. Once you have a model, you need to explore it. That means you have, let's assume, made some network of different dependencies between the different elements. You can look for patterns. As I said, you want to understand something that's emerged, that is more than the sum of the parts, for which there exists a number of methodologies and ideas, looking for cycles, for feedbacks, for systems, for hierarchies, for clusters, etc. You have a model. Ideally, as I said, the model will produce predictions. Try to derive some non-trivial prediction, and then, of course, check whether the prediction is correct, not necessarily by doing an experiment, but maybe you have developed some data, and then you can find in the literature whether the prediction that your model would make is correct. And, of course, critically evaluate your model. No model is perfect. Every model leaves out things, every model is subjective, but you want it to be more comprehensive and less unreliable. So you critically examine it, correct it, make additions, clarifications. And then typically this is a recursive process, an iterative process. Once you have improved your model, you again start the whole thing. You again start looking maybe for variables, maybe for connections, maybe for predictions, etc. So I'll give you just one example of a simplified version of this methodology, which I found recently. It's called Participatory Systems Mapping. It's a modeling methodology where you bring a group of people together. It works pretty quickly, kind of a group like the group we have here now. You bring them together for 2 or 3 hours, and then you start doing more or less the things that I said before. So the group should be the different stakeholders, at least the different experts. That means people with diverse backgrounds. You start listing what are the elements, what are the variables. You start making a map of how the one reacts to the other, and then you can start analyzing that map. So here is a little example that I took from the paper. It's not so important what's there. The core factor was here, it's called BBE energy. That means bio-based energy. The idea is how can we produce more biologically based energy? And then you can see that there are different ways, different things that have positive or negative influences on that energy. This is typically an example that some of you will recognize as systems dynamics. I'm not saying that this is the methodology for transdisciplinary research. It's just one example of a number of methodologies that exist like that. Then transdisciplinary education, well, that's the idea of teaching people how to do these kind of things. And here I found a nice quote from a recent review of paper on transdisciplinarity, which says, what sets transdisciplinarity apart from other approaches and what assures its role in 21st century education is its acceptance of and its focus on, and this is important, the inherent complexity of reality that is seen when one examines the problem of phenomenon from multiple angles and dimensions. Because this is indeed, reality is complex, reality is a network of entangled things. That is the first thing you need to accept. And ideally, what you hope to achieve is with a view towards discovering hidden connections between the different disciplines, where the different disciplines are the partial views on your complex phenomenon. Then this transdisciplinary education at CLEA, well, we are moving towards that. I don't think we are fully there yet, but we have already this long tradition of CLEA seminars, of which this is one where typically we have these small groups of people with very diverse backgrounds which get together about a particular topic presented by a speaker. But then after the speaker has presented this particular perspective, there's typically a very long and pretty intense discussion for at least an hour or more. That's one of the methods we have been using informally. We have in principle an interdisciplinary PhD program, although the bottleneck is to find somebody who wants to supervise it, but we have had several PhDs, like for example, the one Peter who's sitting here, who have been guided in that way by having these seminars, by participating in these seminars, by getting feedback from people from lots of different perspectives. We have since recently a school of thinking, which I'm not going to go into details about because it's much too much to speak about it. I myself give some courses on what I might call integrated worldviews, a bit an overview of sciences of evolution, systems theory, complexity, cognitive science. And then we are hoping, and that is part of why we started with this seminar, that in the future we might offer some general courses to the VUB on transdisciplinary research methods. So some of the things that might go into these courses would be foundations of scientific modeling. That means what is it really what you do when you are scientists, you do research, you make a model, what are you doing, what are the fundamental assumptions? A number of practical methods and guidelines, like for example, this participatory systems mapping methodology that I just sketched. It would be good to have a number of cases of examples of transdisciplinary research where these methods have been applied. And ideally, you would invite the students in such a course to also bring some of their own research and to analyze it in this way. So I'm getting to the end of my talk. I just wanted to mention some other research that CLEA has been doing in this very broad transdisciplinary phenomenon. I spoke about first the practical research, the real world problems. Then I spoke about what I call the out of the box research. And this is something maybe that's what CLEA has been doing most. We have had some really very out of the box research. Just some examples here. I already spoke about quantum cognition. Another one is the idea that you can analyze the activities on the internet as if the internet would be a brain. An example of a PhD student of mine, Carlos Gershon's son, who got the bright idea of designing self-organizing traffic lights. That means that the traffic lights are not steered by a program, but that they are steered actually by the cars that are going from the one to the other. An idea of Shimabeji, mindfulness engineering, which is typically one of these combinations of two things which at first sight have nothing to do whatsoever. Like engineers are these hard people and mindfulness, these are these softy yoga kind of things. Yet you could in principle engineer to make it more
are there to support, the whole faculty, kind of give that little, takes it outside of the day-to-day. In terms of the regulations, the programs, the students, that day-to-day kind of troubleshooting kind of stuff. So I think that, that's my.
It wasn't.
Oh. A topic that Clément Vidal is working on. Also, at first sight, a pretty crazy idea is Talivores, which is the idea that there are stars that are eating other stars, for which there is some evidence that there are stars that indeed absorb material from other stars, but to interpret those as living systems. Open-ended intelligence, which is the idea that intelligence does not need to be limited to human brains or to computers, but that there is intelligence kind of in the whole world, in the self-organizing of the whole world. Social systems programming, that's a paradigm where we were looking at social systems as kind of parasites of people who impose norms on the people more to maintain themselves rather than for the good of the people. Entanglement of images, that's this idea of quantum entanglement, but now applied to photos. Paradoxes in organizations, that's what Peter made his PhD on. Nutrigerontology, which is the idea that you can study aging or improve aging by looking at nutrition. Ecosystems as reaction networks, which is that you apply modeling methods used from chemistry and computer science to model ecosystems. Mathematics of anarchism, that's EVO, that's anarchism, because I see the last thing to which you want to apply mathematics, but you can. Cybernetic theater, having people perform while following certain algorithms, and negative poetry, writing poetry by some algorithm where you negate everything that has been said in a poem. Just some examples of out-of-the-box research. And finally, some examples of the transdisciplinary unification research, where, of course, we have lots of experience in looking at the foundations of science, at the integrating worldviews, at the kind of a big history perspective of the evolution of complexity from the Big Bang until now, at systemic modeling which doesn't care precisely what it is you are modeling, but looks at the system's reactions. And most recently, the Templeton project, with a project on a science of purpose, a new kind of science where goal-directedness is no longer outside of science, but can be looked at part of science. So this is a quick overview of some of the ways that we have been doing transdisciplinary research in CLEA, and let's say a plea for developing these methods that we have been using implicitly into a bit more structured approaches, which then could become courses on how to do transdisciplinary research.